In this video, I'm going to solve some trig equations with sine in them, and I want to use the calculator to do it. So here's our first example. Sine of theta is root 5 over 6. Now we're only looking between 0 and 2 pi. So the first thing I can do is go ahead and rewrite this as theta is sine inverse of negative 5/6. So what we need to do is plug that in our calculator. Now make sure your calculator is in radian mode. We're given a domain to look on between 0 and 2 pi. That is definitely in radians. So make sure the calculator is in radian mode. Okay, so this is what we get approximately when we plug sine inverse of root 5 over 6 into the calculator. So approximately 0.3819. Now let's take a look at what this means in terms of the unit circle. So remember, sine is the vertical distance corresponding with these points. And what I did is I put root 5 over 6 into the calculator and I got about 0.3727. So this red mark here represents that distance. Now it looks like I made it a little bit too long, but let's just go with it. Now that vertical distance will correspond with the points associated at these two places on the unit circle. Now we know from the calculator that we get 0.3819 radians as this arc length. Next, I want to find the measure of this angle. Okay, so this angle associated with this point on the unit circle. Now, notice by symmetry that this arc length that is 0.3819 radians is equivalent to this arc length over here in the second quadrant. So that means if I take pi, which is represented here, and I subtract that 0.3819, I will end up with the radian measure at this point. So pi minus 0.3819 gives me 2.7597 radians. So I labeled it right there. So that's our two answers for this equation. So for sine of theta is root 5 over 6. There are two answers, one in the first quadrant, one in the second quadrant. So here they are approximately. Now notice that whenever you have an equation like this, you will in fact have two answers because that vertical distance yields two separate points. So one over here in the first quadrant, one over here in the second. Next, let's solve when sine of theta is a negative value, negative 8/9. And notice that I'm still looking between 0 and 2 pi. Now, if we just go ahead and rewrite to begin with, theta is equal to sine inverse of negative 8/9, and I plug that into the calculator like I did before, what I end up with is a negative value, negative 1.0949 radians. Now let's take a look and see what that means as far as the unit circle goes. So just like I did before, I'm considering a vertical distance because I'm talking about sine, and I approximated the negative 8/9 to be negative 0.8889. So that represents this vertical distance in red. So there are two places on the unit circle that will be represented by that vertical distance. Now the first one that I found is right here. Now again, notice that it's negative. Remember, like we said before, that when you're talking about sine inverse, the output lives between negative pi over 2 and pi over 2. So when I put that in the calculator, I will be going in the clockwise direction and I'll be given a negative angle. Now, that doesn't lie in our domain, which is 0 to 2 pi. So what I'm going to need to do is add 2 pi, so I'll be going all the way around the unit circle there, and it'll give me a positive value, 5.1883 radians, which does in fact lie between 0 and 2 pi. Okay, so next I need to look at this point over here. I need to figure out this radian measure. Starting from here, starting from 0, this radian measure. Okay, so notice that this arc length right over here is equivalent to this arc length. Now, the measurement of that arc length would be 1.0949 if you think about going in the positive direction. So if we start with pi and we add, what we'll end up with is 4.2365 radians, which is in the third quadrant, definitely between 0 and 2 pi. So I've labeled it right here. So this 4.2365, that represents, starting from 0 here, this radian measure. So those two will be my solutions to this equation. Sine of theta is negative 8/9.